Space vector. So, space vector is a set whose elements, often called vectors, denoted by the capital letter V, may be added together or multiplied by numbers called scalar. Mostly, it is denoted by the capital letter F. Scalar are often real numbers but can be complex number or, more generally, elements of any field. So space vector space definition: a space comprised of a vector collectively with associative and commutative law of additions of vectors, and also associative distributive process of multiplications of vectors by scalar is called vector space or space vector. Vector space consists a set of vector elements of V called vectors. A field F elements of scalars are often two operations. So vector addition is an operation that takes two vectors and it produces third vector. Scalar multiplication is an operation that takes scalar and a vector and it produces a new vector. So our objectives is a define the scalar product of two vectors, state some important properties of scalar product, calculate the scalar product when two vectors are given in a Cartesian form. Use the scalar product in some geometrical application. So, definition of a scalar product. Study the two vectors A and B drawn in the figure 1. Note we have drawn two vectors so that the details are at the same point. The angle between two vectors have been labeled theta. So this is the figure. So the scalar product of A and B is defined to be A times B is equal to the absolute value of A times the absolute value of B times cosine theta, where the absolute value of A is the modulus or the magnitude of A, and the absolute value of B is the modulus of B, and the theta is the angle between A and B. So example, consists the two vectors A and B shown figure 2. Suppose A has a modulus 4 units, B has a modulus 5 units, and the angle between them is 60 degrees as shown. So, we can use a definition given above to find the scalar product of A and B. So, the formula is A times B is equal to the absolute value of A times absolute value of B cosine theta. So, since our A is 4 units of 4 and our B is 5, so 4 times 5 times cosine 60 degrees, which is our angle between A and B. So 4 times 5 times the value of cosine 60 degrees is 1/2. So 4 times 5 is equal to 20 times 1/2 is equal to 10. So the scalar product of these vectors is number 10. Note that the answer is a scalar that is a number rather than a vector. So we can have learned a method combining two vectors to produce a scalar.